Hi everyone. This video is inspired by Stephen Hawking, who I'm sure you would have heard passed away recently, and that is sad. Especially as a physics student, I was heavily inspired by people, including Stephen Hawking. I remember that his book, A Brief History of Time, was, I think, the first physics book I ever checked out from my school library. So I feel like I've gone through my physics education looking up to him as one of the role models in physics. So it was really sad to hear about him passing away. But today I thought I'd play some universe Sandbox, do some black hole physics, and maybe look at some Hawking radiation. So it's been a while since I played this game, and I feel like I have probably forgotten how to play, but that's alright, we'll see how we go. When I add a black hole, I think a black hole 100 times the mass of the sun sounds alright. So let's just put that out there. It's useful to have a little bit of stars in the background for this, so you can actually see the black hole. So black holes are pretty terrifying. I think that's one of the most interesting things about them though, and that's one of the reasons why I like the work of someone like Stephen Hawking so much, is that he talks about these really interesting and fundamental ideas about physics. Let's see if we can add some things in orbit around here. Get some stars, we've got the sun. Okay, how do I launch this? Let's just put a few suns out here somewhere. Okay, where are we? Okay, they were launched nowhere near the black hole. Let's do this from a bird's eye view, that might be better, and let's give it a pause as well. Okay. Here we got a few a bit closer in there. And play. Okay, so we can see them being ripped apart by the tidal forces of the black hole. I spoke about this a bit in my last video about gravitational tidal forces and how they rip apart objects. Okay, I wanted to put some things in close to this black hole so that we can start to get a bit of an accretion disk building up around it. I don't think we're close enough yet. So let's go right in close. Oh, it looks like we have a supernova happening out there from some suns that are colliding. Let's ignore that. Let's go. Oh, well, at least you can see the black hole now, because the dust from the supernova is lighting things up a little. A black hole has an event horizon, and that's sort of this blackest area around the outside, this sort of rim. And at that point, pretty much light can't escape. So anything that goes past the event horizon, like the attraction pulling it inwards is so strong that even light can't escape. You can't escape once you're at that point. And so that's why black holes are black, and it's because light can't escape. But Hawking radiation is about the idea that something is actually emitted from a black hole, and that is something called Hawking radiation. And it's something that will eventually cause the black hole to lose mass and dissipate away to nothing, which is interesting, as opposed to the idea that they just stay there forever. So the explanation I've heard is that at the very rim of the black hole, you've got virtual particles. So you've got pairs of particles, like particles and antiparticles, popping into existence in pairs, and usually they would annihilate each other pretty much instantly and disappear. But if you've got these particle and antiparticle pairs originating at the very rim of the black hole, then one of the pair would be essentially sucked into the black hole, leaving the other one of the pair to have nothing to annihilate with, and to escape away from the black hole. And essentially that is the Hawking radiation. It's material or particles that are leaving the black hole. The particle that would get sucked into the black hole would have a negative mass, and so that would give the effect of the black hole itself losing mass. So let's talk about a few other things now. Take a look at a few other setups here in Universe Sandbox and talk about some of Stephen Hawking's quotes and things that he said that I thought were interesting. So we've got the solar system here. Let's zoom in on Earth. Here we are. Oh, that's nice. Let's slow it down. Alright, so this is more of a real-time sort of thing. 1 Earth second per game second. Where are we going to look? Australia's in the dark, but we can go over there. So one quote that I wrote down is something that I've heard attributed to Stephen Hawking, and that was the phrase, "Look up at the stars and not down at your feet." Now this is something that I thought was interesting because this was something that I used to say. I used to think, the most magical thing you can ever think about is space, is to look up at the stars and imagine sort of our place in the universe and what's out there, just to see us in the grand scheme of things. I still can't really think of anything more beautiful than that, and more important as a way to level ourselves and to see how we fit into the scheme of things. But I don't necessarily think it is a bad thing to also look down at your feet. I think that whilst you can gain a lot of perspective from looking up, that perspective might almost be lost if you're missing the things around you in your day-to-day life. If you're not looking down at where humans have come from and our origins and how we interact with each other today, and relating that to the bigger goals you might have looking up and the bigger dreams for humanity, I think it would be a shame to ignore the importance of what's down here for us now. There's a lot of beauty in life on Earth, and I think it took me a little bit longer to realize that and to actually find wonder in the everyday things and beauty in the everyday things, instead of only looking to space and astronomy to find beauty. So looking back at the simulation, this is actually a particularly cool setup here, because we've got the Earth, we've got the Moon out here, and then if we keep zooming out, that's the trajectory of the Earth. Oh, what's this? We have the Tesla Roadster. Zoom right in on that. And there we go, there's us. And that's should be kind of representative of where the Roadster is now, I hope. So, it's got pretty far, but in terms of celestial distances, it's still much, much closer to Earth than it is to Mars or anything else at all. So it's going to need to be keep driving for a while, but it'll get somewhere. And another quote from Stephen Hawking that I thought was interesting was one where he said, "The human race doesn't have a future if it doesn't go into space." And you know what, I believe in that. I think humans need to go to space. I think it's just as important as, solving problems on Earth. In the really long term, that is. To me, there's a lot of reasons why I believe we should go into space. One of them is just that it's that natural human desire to want to explore around us. People many, many years ago wanted to explore the other countries on the Earth. They weren't just content to stay in the country they were born, in the country they knew. They wanted to see what else was on the Earth, and we are now glad that they went out and explored, because we live in all parts of the globe. And I think it's sort of that same feeling. I feel like it would be a massive shame if all of humanity only ever existed on the Earth, on this very tiny corner of things. So space travel also plays a huge role in giving us unity and giving us a perspective as, you know, needing to come together as one planet and one nation, really, to be able to go out and explore space or the solar system or anywhere. I think we do need to recognize ourselves as being united in a sense. And I think space travel is one of those things that, you know, would hopefully unite people to a common goal. And I really look forward to that. I really look forward to seeing people do more in space travel and to seeing more people do it as a collaboration. For our next stop, let's go and look at some exoplanets. Alright, so we're off to TRAPPIST-1, a red dwarf star nearly 40 light years from the solar system. It has 3 Earth-sized exoplanets discovered. Well, that was before they discovered 4 additional exoplanets. So, you know, some of these planets here could be quite like Earth and potentially a second home for us, if only we could travel a few light years to get here. You know, the fact that they are like Earth means that even if we can't get here, possibly what does live on some of these planets, if there is any life out here, you know, could have evolved similar to life on Earth. There could be some similar conditions. If these planets are also in like a similar Goldilocks zone in terms of temperature, the ability to have water, oxygen, and atmosphere, it's plausible that things could have evolved out here similar to life on Earth. And maybe that leads me to my next philosophical quote from Stephen Hawking. He said that in his opinion there is no aspect of reality beyond the reach of the human mind. Now that's an awesome quote, and you know, I think it's true to some extent. Stephen Hawking kind of demonstrated that through his life and his philosophy, where despite being physically held back by an illness, he didn't let that hold back his mind, and he essentially traveled the universe many times in his mind, and unraveled secrets about the universe, about how black holes work and all sorts of things. You know, from the comfort of Earth, we can imagine our way to any place and do pretty much anything with our imaginations. One thing I struggle to do with my imagination, and I think people struggle to do in general, is to actually imagine what life would look like elsewhere in the universe. So I feel like humans may be forever limited to imagining extraterrestrial life that is similar to life we already know, life on Earth. I feel like all the depictions of aliens I've ever seen have been based on, you know, odd-looking humans or odd-looking animals. I feel like I've never really seen a depiction that has actually thought outside the box, and I feel like maybe the human mind is just configured to only ever imagine life the way we know it. You know, I'd want to believe that there could be life out there that doesn't exist in a physical form at all, that is just essentially, you know, a cloud computing network existing that covers some planet out there. But I can't really imagine or fathom that, and you know, I would love to see some more depictions of alien life that isn't based on Earth life, because I don't think it should be. I think that given the fact that conditions would be so different for life to develop, and that they might have had vastly different timescales, maybe so much more time than us to develop and to advance, how could we ever possibly assume that it's going to be similar to life on Earth? that's one thing that I find, you know, hard to imagine, but I love trying to picture it. Maybe out here in the Trappist system, you know, some of that life exists, and I wonder what it does look like. Alright, I'm going to read you one more quote, but I'm looking for a simulation that's sufficiently philosophical. Voyager 1 in the solar system, that seems, let's see what that's like. Alright, so this is going to be a simulation of some of the NASA Voyager probes. Let's see where they're at. Okay. Here's Voyager 2. Oh, I've been zooming for a while. It must be small. Does it exist? Is there a picture of it? Oh, that's dark. Is there a light in this game that we can get a silhouette? And now let's go look for a light. View. Studio. Okay, oh yeah, we can see Voyager 2 out here. The last quote I was going to read was one from Stephen Hawking that I think is quite beautiful. He said that we are all time travelers journeying together into the future. It is now up to us to make that future a place we want to visit. I think that's nice. You know, the Voyager spacecraft is venturing out into the future. It's going to get further than we're going to get, considering none of us have left yet. But you know, if we can go all the way back to Earth, even earthbound, we are voyaging as well into the future, and whether it's on Earth or just outwards into the solar system, we want to make the future somewhere worth venturing into. So I hope that's a little bit of motivation for your day. Thanks for watching. I don't know if you've noticed, but I have been a little bit absent from YouTube in the last few weeks. I at one point promised to make 2 videos a week, but I haven't quite been able to manage that, I think. I've just been really busy with PhD stuff, a little bit stressed. I'm trying to make as many videos as I can, and I've got a few exciting ones lined up to make in the next week, so we'll see how they go.